Yeah, good evening everyone. Good evening. Good evening. Yeah, good evening. I think this is the place where we stopped in the yesterday's class. Yesterday's class we stopped here. So I think today's date is 12/8/26. This is the today's date. Let's start here. So in the last class we discussed about bipartite graph, right? This is the bipartite graph starting. It is a bipartite graph starting. So let me write here. Topic is bipartite. Bipartite graph. So bipartite graph. So this is the explanation. So given a graph is a bipartite graph or not, I verified all these conditions satisfied. So given a graph is a bipartite graph, right? Bipartite graph means if you can divide a given graph into two parts by satisfying these conditions, then it is a bipartite graph. I verified one more example. Is it bipartite or not? I tried, but within the n group, there is a edge. So one of the condition is violated. So given graph is not a bipartite graph. And I took one more problem, right? I tried, but within the n, there is one edge is coming. So condition is violated. So given graph is not a bipartite graph. It is not a bipartite graph, right? So I think see this one. It is a bipartite graph. It is a bipartite graph. It is a bipartite because within the m no edge. Within the n also no edge. If anyone asks, is it bipartite graph? Yes. Because within m no edge. Within n no edge. Every time edge from m to n. So it's a bipartite, it's a bipartite, it's a bipartite. But remember, in the given bipartite graph where partition is 2, 3. In the given bipartite graph where partition is 2, 3, where in the m, right? Every person is adjacent to in the m. In the m, every person is adjacent to, right? All vertices of n. So that is called complete bipartite graph with the partition 2, 3. This is called K23. Right? Complete bipartite graph with the vertex partition 4, 2. So this is called it's a bipartite graph 4, 2. Okay, complete bipartite graph 4, 2. So short notation is K42. K42, how many edges are there? So K42, how many edges are there? If you want, you can find out sum of degrees. For the first person 2, second person 2, third person 2, fourth person 2, fifth person 4, sixth person 4. So here 4 times 2, 4 2 is 8. Here, right? 2 times 4, 8, 8 plus 8, 16 by 2, so 8, which can be written as simply 4 into 2. So if you do sum of degrees, which is the 2e by 2, which is going to be same. So otherwise, simplest answer is m into n you can do. M into n. M is 4, n is 2, m into n. So number of edges in the complete bipartite graph m comma n is mn. Number of edges in the complete bipartite graph 50 comma 25 is 50 into 25. 50 into 25. I feel everyone is comfortable till here. Right now, I will go to the next story. In the last class, until here we done. In the last class, until here we done. Now I will ask you one small question. Please listen, everyone. Please listen, everyone. One small question I want to ask everyone. In careful, this may be note 1. Be careful. It's not a problem at some points. Careful everyone. It is a note. First point. See, answer everyone. In bipartite graph. Remember, it is a bipartite graph. In bipartite graph with vertex partition 4, 3. In bipartite graph where vertex partition is 4, 3. Minimum edges how many? Maximum edges how many? I want to know. In bipartite graph with vertex partition 4, 3 means 4 people here, 3 people here. Minimum edges how many? Maximum edges how many? Remember? It is already bipartite graph. Minimum edges. Minimum edges 0. It is not a complete bipartite graph. It is simply bipartite graph. In bipartite graph with vertex partition 4 comma 3, in bipartite graph with vertex partition 4 comma 3, minimum edges 0. Maximum, I think when you say bipartite graph, maximum means complete bipartite graph. Keep maximum. Everywhere max. Everywhere max. Everywhere max keep. Which is nothing but everyone, no? 4 into 2, which is 8. Right? So this is a very, very important one. In bipartite graph, vertex partition 4 comma 3, minimum edges are 0. Because if no edge there, then also bipartite graph. Maximum is everyone connected to everyone. Everyone in the M connected to everyone in the N. Everyone in the M connected to everyone in the N. Then you will get the maximum, right? Be careful too. Be careful in, it's not bipartite, no, complete bipartite. In complete bipartite graph, in complete bipartite graph, where vertex partition is 4 comma 3, which is nothing but K43. K43, minimum edges how many, maximum edges how many? Minimum edges how many, maximum edges how many? So we have to calculate. In complete bipartite graph with vertex partition 4 comma 3, which is called K43. Minimum edges how many, maximum edges how many, we have to calculate. I think because of it's a complete bipartite, complete. When you say complete, no maximum, no minimum. Answer is 4 into 3, which is 12. Answer is 4 into 3, which is 12. Everyone know this. When you say complete, no minimum, no maximum. When you say simply bipartite, then edges may be there, may not be there. If edges there, maybe more there, maybe less there. Right? Everyone in the M adjacent to everyone in the N. M into N edges. M into N edges. So be careful. If it's bipartite, you have chance. Edges may be there, may not be there, may be fully there, may not be there. But when you say complete bipartite, compulsory edges should be there. Minimum also 12, maximum also 12. Everyone know, which is nothing but Mn. M into N. M into N. Right? This note, I hope everyone is fine now. This note, everyone is fine now. Now, in one of your previous paper, this question is given. Please try to give answer. Very less people will give answer for this. Very less people. See the question, what is given? Careful. Let me write. In 6 vertex, complete bipartite graph. It's a very, very interesting question. In a 6 vertex, complete bipartite graph. In 6 vertex, complete bipartite graph, how many edges are there? In a 6 vertex, complete bipartite graph, maximum, how many edges present? Maximum. It is a very, very good question. It is one of your previous paper. This question is given. In 6 vertex complete bipartite graph, maximum how many edges present? Can anyone give answer? Please help me if you can give answer. In a 6 vertex complete bipartite graph, maximum how many edges are present? In a 6 vertex complete bipartite graph, maximum how many edges present? Can anyone help? In 6 vertex complete bipartite graph, maximum how many edges present? Anyone give answer? Please check. I will try. But the problem here is complete bipartite, he said complete bipartite. See the answer. He said complete bipartite. Okay. Total vertices, 6 vertices also he mentioned. He mentioned totally 6 vertices. Okay, no problem. M and N, if I add, total 6. Complete bipartite means bipartite it is. First of all, it is a bipartite. It didn't mention how the partition. 6 vertices he mentioned. Complete bipartite. When you say bipartite, partition should be there, na? Partition. So it will be M, it will be N. But he didn't mention how many will be in the M, how many will be in the N. But one thing is true. Bipartite graph contain two parts, M and N. In the M, at least one node should be there. In the N also, at least one node. But he didn't mention how the partition. So you have to check on how. So M may be one person, N may be 5 people. M may be 2 people, N may be 4 people. It may be 3, it may be 3. It may be 4, it may be 2. It may be 5, it may be 1. Am I right? So these are the possibilities. First possibility, second possibility, third possibility, fourth possibility, fifth possibility. Totally there are 5 ways are there. Because of he didn't mention bipartite how the partition is done, we don't know. Complete bipartite. Complete okay. Bipartite also okay. But he didn't given how the division. So all possibilities you take. That is the reason he's asking. Maximum edges how many? Maximum how many edges present? Suppose this kind of complete bipartite graph 1 into 5 edges 5. If this kind of complete bipartite graph 2 into 4 8. If this kind of complete bipartite 3 into 3 9. If this kind of complete bipartite 4 into 2 8. If this one 5 into 1 5. So he's asking maximum edges. I think this is the answer. Answer is 9 edges. Because of he is not divided, so I should divide. How? Many possibilities. He is asking in which kind of, right? In what kind of complete bipartite graph you will get maximum edges. Remember, if you divide vertices equally, if you divide vertices equally, then you will get the maximum edges in the complete bipartite graph. If you have chance of dividing whatever way you like, then divide like this, then you will get more edges. You have many chances. Because of he said simply complete bipartite. Partition he didn't mention. You can divide whatever way you like. But remember, M should contain minimum one person. N should contain minimum one person. So no group is empty. If I do union, total vertices should come. If I do intersection, nothing common. So how many ways you can construct the bipartite graph? 5 ways. If you go to the first way, maximum edges how many? Complete means more edges. Na? In the first model, edges are 5. In the second model, 8. Third one, 9. Fourth one, 8. Fifth one is 5. So if you want more edges, divide the vertices in M and N equally divide. So same question I will ask you in the place of 6 vertices. If I ask you one more question, I am asking same story. Just I want to ask you same story. 50 vertices, complete bipartite graph. Remember, next problem maybe 50 vertices, complete bipartite graph. Maximum edges how many? Max edges how many? Maximum edges how many? Remember, if you divide equally, then you will get the maximum. M and N. I think 50, na? 25 here, 25 here. Number of edges where complete bipartite graph 25 is going to be 25 into 25, which is going to be 625. 625 edges is maximum. Right? I think people got. Now let me say one more. It is not 50. Let us assume 11 vertices. 11 vertices complete bipartite graph. 11 vertex complete bipartite graph. Maximum edges how many? Maximum edges how many? I think because of 11, equally you may not able to divide. So just to do 11 by 2, 5.5. Take 5.5 floor value one side. Take 5.5 ceiling value one side, which will goes to 5 into 6, which is going to be 30. Equally not possible. No? If equally possible, only one integer will come. Suppose 50 by 2, 25. Equally not possible, plus or minus 1. So floor you take for one person, right? Ceiling you take for one person. 5 plus 6 becomes 11. Right? Edges are 5 into 6, 30. Now listen everyone. Everyone listen. Same thing I am doing, everyone listen. One more problem I am doing. Can you see this one? Please see the answer. Uh, in 6 vertex, complete bipartite graph. Minimum edges how many? Minimum edges is asking. Minimum edges. So if you want minimum edges, I think one side is 1%, another side is 1 into 5. 5. This is the minimum. One side 1, another side remaining. One side 1, another side remaining. Hi, Dheeras. Hi, Dheeras. Hi, Dheeras. How are you? So in 6 vertex, complete bipartite graph, minimum edges how many? Minimum edges how many? So you can divide like this. You can divide like this one. M contain 1, N contain 5, 1 into 5, 5. Right? Check everyone. Check everyone. Right? I'm thinking everyone is perfect. So maximum is that one. Right? Maximum is that. Minimum means I think first division like this. This will give minimum. Or last division. This will give minimum. These two people will give minimum. These two people will give minimum. And there is you can do in your right in your flow you go. In your flow you can go. In your flow you can go. Fine. Total day you have to wait. For one class you have to wait total day. Right? I request you please go in your flow. Right. Now I think minimum means first partition. Maximum means equal partition. Do equal partition. If not equal, floor ceiling. If not equal, floor ceiling. If not equal, floor ceiling. Right? Fine. Now I think I will do the same thing. Let's check here. I will do the same thing here. Let's check here. So carefully observe. Just let me complete these formalities also. See this. In n vertex, yeah, bye. In n vertex, complete bipartite graph. In n vertex, complete bipartite graph. In n vertex, complete bipartite graph. Careful. In n vertex, complete bipartite graph. Maximum and minimum edges how many? This is the question. N vertex complete bipartite graph, maximum and minimum edges how many? So I think n vertices, no? See, because of is not given partition, you do partition whatever way you want, mn. So 1 n minus 1, 2 n minus 2, 3 n minus 3, and so on. N by 2, n by 2. Right? I think further it will increase. N by 2 plus 1, n by 2 minus 1. It will continue. Lastly, if you observe, Lastly, if you observe here, it is going to be n minus 1, here 1. Right? But if you want maximum edges, you should divide like this. N by 2 into n by 2. Right? N by 2 whole square. This is the maximum edges. Right? If you divide like this, minimum edges. Right? Like this. Suppose exactly not possible. Assume exactly not possible. Suppose exactly not possible means it is not a even number. It is an odd number. Then what you do? N by 2 floor into n by 2 ceiling. N by 2 floor, n by 2 ceiling. N by 2 floor, n by 2 ceiling. If at all exactly not possible means this is for odd number. This is for even number. These are maximum edges. So please be careful. This is a very interesting problem. In n vertex complete bipartite graph, maximum and minimum edges how many? Because of is not done partition, we can do partition by ourselves. In what way I should do partition so that I will get more edges? In what way I will do partition so that I will get the less edges? So we have to decide ourselves. Okay, I think bipartite graph, complete bipartite graph we completed. Complete bipartite graph we completed. So please be careful. Right? You completed that. Now let's go to one small thing. One small thing there, that also please take care. Right? Careful. Everyone careful. A, B, C, D, E. I think if you observe clearly, there are 5 vertices here. There are totally 5 vertices here. Remember everyone. Right? This is called star graph. This is called star graph. This graph is called star graph. This graph contains 5 vertices. This graph contains 5 vertices. This is called star graph. Star graph with 5 vertices. This is called star graph with 5 vertices. With 5 vertices. Right? Let me write one more star graph. Let me write one more star graph with 6 vertices. Or I can do star graph with 4 vertices also. Same thing. A here, B here, maybe C here, maybe D here. It is a star graph with 4 vertices. With 4 vertices. Next, star graph with 5. So I think if you want, you can give one more EF. Write properly. Right? I think we can expand. We can decrease the some difference, whatever it is. A, B, C, D, F. Totally 6 vertices. Star graph with 6 vertices. So I think if you observe clearly, this can be written like this. This can be written totally, I think 5 vertices. Now, one vertex you can write in the n. Other vertices you can write in the n. What are the other vertices? A also, B also, D also, E also. From here, all are there. If you observe clearly, it is K14. Totally 5 vertices, na? K14. If you observe clearly, it is K13. If you observe clearly, it is a K15. K14 contain 1 into 4 edges, 4. K13 contain 1 into 3 edges, so 3. K15 contain 1 into 5 edges, 5. Right? Be careful. Be careful. Star graph, right? This is the star graph. If you don't know, you may think that it is very complex. You may think star graph is very complex. You may think like that. The story is called star graph. I am writing here. Star graph. Remember, it is a star graph. It is a star graph. Remember everyone, it is a star graph. Star graph with 5 vertices, star graph with 4 vertices, star graph with 6 vertices. Star graph with 6 vertices can be written as K15. Star graph with 4 vertices can be written as K13. Star graph with 5 vertices can be written as K14. 1 into 4, 4. 1 into 3, 3. So like that. This is star graph. I hope no one having any objection. If you have objection, let me know. Ready, sir? I have this objection. You say to me, I will take care. Yeah, one important topic is going to start now. Please observe everyone. One very, very important topic is going on. Remember, whatever we are discussing are simple graphs only. Multi-graph we don't discuss because multi-graph, right? Most of the questions answer contain infinite. Multi-graph, most of the questions answer contain infinite. In the multi-graph, no, most of the questions answer contain infinite. Right? Be careful. Right? I'm starting now because of everything is okay. Because of everything is okay. Make sure because of everything is okay. Right? Now I'm going to the next one. Right? Remember, we are discussing about only simple graphs. Because multi-graph answer mostly will go to infinite for most of the problem. So we don't discuss. We will discuss only simple graph. Right? So I think so many graphs we covered. One is null graph, one is complete graph, regular graph, cycle graph, wheel graph, bipartite graph, complete bipartite graph. Next one is a star graph. Many things we covered. Don't by heart, meaningfully study one time. Don't by heart. Now observe. Very, very important topic is going on. That is called planar graph. Planar graph. Right? That name is called planar graph. Be careful. This is the very, very important one. This graph is very, very important. What is the name of the graph? Planar graph. Right? Planar graph. Right? What exactly planar graph? Everyone observe. This is the one of the important thing in the graph theory itself. In the graph theory, this is one of the very, very important thing. Most of the questions will come from here. Most of the questions in the graph theory will come from planar graph. Right? So I'm starting now. Planar graph, everyone observe. Planar graph, everyone observe here. Everyone observe. Right? Everyone observe what is a planar graph. Say this. A, B, C, D. I want to check the given graph is a planar graph or not. Please be careful. I want to check given graph is a planar graph or not. This graph contains 4 vertices. First of all, it is a simple graph, right? We are discussing simple graphs only, no need to write again and again. So it is a simple graph first of all, right? It is a simple graph which contains 4 vertices. I want to check is it a planar graph or not. So what you do is, please observe clearly in the given graph, careful. In the given graph, no edge crossings, no edge crossing. So given graph is planar graph. Given graph is planar graph. That's it. In the given graph, in the given simple graph, if you want, you can write. In the given simple graph, no edge crossing. So what is the meaning of edge crossing? Like this. In the given simple graph, no edge crossing. So given graph is planar graph. So be careful. No edge crossing. See, nowhere crossing there. See, edges can touch like this. This is okay. You can touch the edges, but crossing cannot be there. It cannot be like this. Crossing cannot be. No crossing, edge crossing not there. At one vertex they can meet. At a particular vertex they can meet, but edges cannot cross. So given graph is a planar graph. I think one problem we done. Let's go to one more problem. Everyone observe. One problem we done. This is one problem for planar graph. Let's see the one more problem for planar graph. A, B, C, D, right? Perfect. Like this. This graph is a planar graph or not? Let's verify. This graph, 4 vertex graph. It is a 4 vertex graph. Okay. I want to verify, is it a planar graph or not? Is it planar graph or not? Given one is a 4 vertex graph. That's okay. How many edges are there? I think 6 edges. 6 edges, 4 vertex, simple graph. 6 edges, 4 vertex, simple graph is given. Okay, it's given. We have to verify, is it planar graph or not? How to verify? See the answer. Edge crossing is there? Yes. See the answer. Edge crossing is there. A, B, C, D. See, everyone observe. A, B, C, D. A, B, C, D. So let me write the edges. Without crossing, let me try. I'm writing now. Let me try to draw same graph without edge crossing. Let me try sorry for this. Let me try to draw same graph without edge crossing. Let me try to draw same graph without edge crossing. Remember, given graph contain 4 vertices. I written all. 6 edges I written till now. 4 edges, 2 more edges left out. So I written this edge also. Till now no edge crossing. Till now there is no edge crossing. So now B2C one edge there. See this one. B2C one edge there. B2C one edge there. If you go inside, edge crossing there. Let's write outside. So if anyone asks you, given graph is a simple graph or not? If anyone asks you, given graph is a simple graph or not? Directly, if you see edge crossing not there, so given graph is a planar graph. See the above problem. In the above problem, no edge crossing. Right? Directly edge crossing not there. In the given simple graph, no edge crossing. So given graph is planar graph. Now in this simple graph, whatever is given, is it planar or not? Right? So directly if I see edge crossing is there, can I draw same graph without edge crossing? Let me try to draw same graph without edge crossing. Yes, you draw. Yes, possible. Then given graph is a planar graph. That's it. Right? Given graph, if you draw without edge crossing, then that graph is a planar graph. So second problem also planar graph. First one directly planar graph. Second one is indirectly planar. By seeing the graph, don't decide it's not planar. Oh, edge crossing is there, it is not planar. Don't say that. Can you draw? Directly no edge crossing, no issue, planar. Suppose directly edge crossing is there, can you draw without edge crossing? Try. Let me try to draw same graph without edge crossing. Yes, possible. I tried. So given graph is a planar graph. Right? So this is the way how to check given graph is planar graph. If the problem is a little complex, you will face some difficulties. Right? We'll see within few minutes, we'll see some other story. So in front of you, there are two planar graphs. In front of you, there are two planar graphs. Try to understand. Now here itself, I will conclude some small story. Here itself, I will conclude some small story. Remember, planar graph will divide the plane. Planar graph will divide the plane into some regions. Total, if you think a total board is one plane, planar graph will divide the plane into some regions. You may say, what is that region? Right? So see this one. This entire thing is one region. See, this entire thing, one region. Assume R1. Right? That closed thing is called as one region. Now, if you see outside, one more region. Two regions are there. Now, one more thing. This is right. It is a one region. It is a one more region. So, if you observe clearly, right, the degree of this region is the degree of this region. So, how many edges are associated in this closed, right? In this closed wall, it is almost like a room. Very simple. Inside is one room, outside is another. Outer region is the inner region. Two regions are there. Planar graph will divide the plane into some regions. If you observe clearly, region is nothing but one closed path. See, this entire thing is nothing but one region. So, degree of this region is equal to 4. 4 edges are associated. And if you see the R2 region outside, see, outside there are 4 people. Outside, degree of region 2 is 4. Right? Now understand everyone understand. So sum of degrees of region, let me check. First region, R1 region degree 4, R2 region also degree 4. 4 plus 4 is 8. 8 can be written as 2 into 4. Remember, sum of degrees of region, which is 8, is equal to 2 into E. 2 into number of edges. See, number of edges are 4. Sum of degrees of regions. Sum of degrees of region, which is equal to 8, which is equal to 2 into E. Like sum of degrees of what he says. Here regions. 2 into E. To get the clarity, come here also. Say, remember, same graph I drawn like this. Can you come here, everyone? You may face some difficulty, please listen. So, this closed path, one region, R1, its degree is 3. This is also one more closed path, something like one room. It is a one more region. Total house divided into some rooms. Every room is one region, right? So R2, that is going to be, it is also, I think, degree 3 because 3 edges are associated. If you observe clearly, this is also one region. It is R3. Edges are 3. Check. And one more interesting thing, outside house also one region, outside of house, it is R4, right? This is also region. If you see the degree, 1, how many edges you can see? From this place, how many edges you can see? I think this one you can see, this one, you can move also, right? Totals outside you can move. This also, I think 3, 1, 2, 3. Outside you are seeing outside 3. Now sum of degrees of region, if you observe, R1 is 3, R2 also 3, R3 also 3, R4 also 3, which is 12, which can be written as 2 into 6. If you want, you can check this 6 is edge. 6 edges are there. Sum of degrees of region is equal to 2 into E. Right? This is called sum of degree, right? Degrees, right? Degrees region theorem. Right? I will write. So I think let me explain this. Right? People are asked if anyone having doubt, why to join EPT? If you have doubt. All classes are in English only. Live there, recorded is there. Daily quizzes are there. Doubt solving is there. PYQs also there. Assignments also available, and one more, mentorship also there. Mentorship also there every weekend. For the GATE also, placement also, mentorship is there. And one more, right, strategy sessions will be there every weekend. Every weekend we will give the targets to you. These are our previous year GATE toppers. I wish next year you will also be here. If you are there, if you are studying currently, if you are there in the college top 5, if you are there in the college top 5, we are going to give EPT subscription freely to you. I strongly believe every student deserve quality education with the affordable prices. If you are there in the class top 5, we are going to give EPT subscription almost free, just a platform fee, 2000 rupees you have to pay. The only thing is you should be there in the class top 5. Right? If you are there in the top 5, please send to mail ID info@examprep2.com. examprep2.com. Send the mail, sir, I am there in my classroom, I am the class top 5, so please give EPT subscription freely. We will give EPT subscription freely, just platform fee 2000 you have to pay. You have to send the mail from your college HOD or principal or a college management, confirm this student is there in the top 5. Please give EPT Rise 1000 Initiative subscription. We will give freely. Just you have to pay 2000. That's it. I strongly believe every student deserve quality education. Last year 200 people I given the free subscription. Now 1000 people I am giving free subscription. Last year 2000, last year 200, now 1000. Maybe if God will give more strength to me, next year 10,000 people I will give free subscription. Let's go next. So evening discrete mathematics live class is going on. Right? Next one, 8:30 p.m. 8:30 p.m. Right? RIC course is going on. 8:30 p.m. RIC course is going on. Right? So what is the purpose of RIC course? RIC course contains 3,500 quality questions. 3,500 quality questions are there with video solution. For every subject approximately 300 good questions with video solution. Mostly GATE questions will come from RIC. Last year after GATE exam is over, one student said that 40 questions came from the right RIC course. One more person said 59. One more person said 44. Right? On an average, if you see, right, approximately, right, I think I can say here 40, that 40 plus questions came from RIC. I'm saying clearly, most of the question in GATE examination will come from RIC course. RIC course contain, right, GATE level standard questions, which can come mostly expected question. 3,500 expected questions we are going to give to you. Out of them in the examination, most of the questions will come. One person said that, right? One person said approximately 59 questions came from, approximately 59. One more 44, one more person 49. So I'm giving surety. Last year itself, that is the story. Right? This year I'm saying 2027, more questions you are going to see. I know how much hard work we are doing. Most of the questions will come from RIC. Right? Please use it. Early morning data structure class is going on. For GATE CSE, GATE DA. This RIC course is for all branches. For all branches, this RIC course. Right? This discrete mathematics is for GATE CSE people. And one more, 15th of this month, there is a all India level mock test. 15th of this month, there is a all India level mock test is going on. So I request everyone, please utilize. Next one, C programming is free. It is there in the YouTube also and EPT platform also. Please go through it. Python programming also free. It is there in the YouTube also, EPT platform also. Discrete mathematics also free. It is there in the YouTube also and EPT platform also. Please utilize. I strongly believe every student deserves quality education. Now see here. So within less price, very less price, you can get the EPT subscription. Don't waste money by paying, right, costly courses. 50,000, 1 lakh. Please don't do that. 50,000 rupees, 1 lakh, don't do that. It is really not needed. So affordable prices, very less prices courses are available. Right? You please go through it, go through the exam prep tool website, you find out. Very less prices. Premium courses also very less price. Just some additional benefits. In the premium, you will get the RIC course also, test series also, and right, live classes also. In the affordable, you will get the recorded lectures. You don't get RIC, you don't get test series. Right? Some benefits you may lose, but major thing whichever required available. Right? Whatever is really required, they are available. Some extra benefits you may lose. You can take this or you can take this, whatever you want. Very minimal prices are there. I request everyone, please go through it. Some free resources also available. C programming is free. Java, right? Python programming is free. Discrete mathematics free. Some free courses are also available. You can go. Test series. I'm saying clearly, test series plus RIC. EPT test series plus RIC. Most of the questions will come in exam. Mentorship also. Every Saturday, Sunday, we will give targets also. Every Saturday, Sunday, we are going to give targets also so that your syllabus will be completed faster. And GATE plus top PSU course. If you are preparing for GATE and PSUs, this course is better. Right? Next one. Free resources. Assignments are there. Toppers notes also available. Previous year questions also there. Doubt solving also there. Mentorship also there. Please utilize. Right? These are our EPT students who got very good placements by taking placement course. So these are the placement for DSA course, DSA plus system design, DSA Super 50, DSA Super 300. These are practice courses. This is the theoretical courses, this is the practice. Interview course is there, programming languages courses are there, development courses are there, front end, back end, web app development courses there. These languages anyhow free. Now listen. So one offer is going on, 70% is going on. Please utilize very less price. This is the code which you can use. This is the code which you can use. 70% discount going on, you can utilize. Right. Fine. Until now we done planar graph. Let's come to the planar graph. One more round. Let's go. Let's go one more round. Planar graph, one more round. Let me go. Right. Let's check. I think, yeah. One more example I am giving. See everyone. K2, 3. K2, 3. Is it planar or not? Let me verify. Is it planar or not? K2, 3. Is it planar or not? I will check. So two vertices, right? A here, B here. In the M, 2 people. In the N, 3 people. C, D, E. In the M, 2 people. In the N, 3 people. Right? We have to verify planar or not. We have to verify planar or not. Can you see this one? Everyone observe. 1, 2, 3. Until now, no edge crossing. Until now, no edge crossing. Now see the answer. I think 3 more are pending. 3 more pending. 3 more pending. Can you see this one? 1, 2, 3. Check. If you go inside, edge crossing is there. If you go inside, edge crossing is there. If you go outside, there is no edge crossing. I hope people got it. See this. This is the graph. It is a K2, 3. It's a planar. Every planar graph will divide the graph into some regions. If you want, you can count the regions also. I think this entire thing is one region. It's R1. See this? This entire thing is one region. It is R1. I think it is R2. Outside is R3. Right? Outside is R3. Check. 3 regions only there. Outside person degree. I am writing degree. Degree of R3 is equal to outside edges. How many you can see? Outside. See, I think 1 edge, 2 edge, 3 edge, 4 edge. I think 4. But what about R2 degree? What about R2 degree? I think inside how many edges you can see? 1, 2, 3, 4. I think it is also 4. I think it is also 4. 1, 2, 3, 4. I think it is also 4. Right? Now see this one. Sum of degrees of regions is going to be, what is the answer? Sum of degrees of regions, right? Which is going to be degree of R1 plus degree of R2 plus degree of R3, right? Which is going to be 4 plus 4 plus 4, which is going to be 12, which is going to be 2 into 6. If you want to check, 6 is the number of edges. 6 edges are there, check. I think 2 into 3, 6 edges. Right? So I am writing here sum of, suppose assume that how many vertices are there here? Sir, how many regions are there? 3, na? So this one, I is equal to 1 to, assume that n regions are there. I is equal to 1 to n. Degree of region Ri is equal to 2 into number of edges. This is the formula. Sum of degrees of regions theorem. This is called a sum of degrees of regions theorem. What is that one? Sum of degrees of regions is equal to 2 into E. Be careful. And one more thing I want to say to you. Please listen. One more formula also there I am writing. Careful. Let G be a, careful. Let G be a connected. Let G be a connected simple, first of all, it is a simple graph, na? Let me write simple. Let G be a simple connected planar graph with careful, it's a very, very important one, with V vertices, E edges, and one more thing is R regions. Then, careful, then let G be a simple connected planar graph with V vertices, E edges, and R regions. Then if you want, you can verify. V plus R is equal to E plus 2. Please check this formula helping or not. Check. See the above diagram. In the above diagram, if you observe, right, 5 vertices. And edges, if you see, I think how many? 6 edges. 6 edges. Verify also. Regions are 3. 3 regions. So let me check. V plus R is equal to E plus 2. V is 5. R is 3. E is 6. 2. So 8 is equal to 8. 8 is equal to 8. If you take any planar graph, simple, important thing is connected, right? Connected planar graph. This is the terminology. Suppose not connected. Let's see one more. Let G be a simple, connected is not there, simple planar graph. See, planar graph may be connected, may not be connected. Let G be a simple planar graph. Let G be a simple planar graph with careful, because if I didn't written connected, simply planar graph. Let G be a simple planar graph with Careful. It's a very, very interesting story with VOTCs, E edges, E edges are regions, E edges are regions, and because of it may be connected, may not be connected, and K connected components, Then be careful, everyone. Then V plus R is equal to E plus K plus 1. This is the formula. Same formula over in the place of 2, right? K plus 1, where K is a connected component. Now I will try. Everyone observe, I will give the one rough diagram. First of all, verify is it planar graph or not? Verify. One diagram I am writing. ABC. It is one planar graph. DE is one more planar. Remember, no very edge crossing. The only thing is it is connected graph. Next one, DE. F, G, H, I, G. So remember, this edge can be written from outside. Be careful. So if you observe clearly this graph, first one contain 3 vertices, second one contain 2, third one contain 4. 5 plus 4, 9. 9 vertices. Next one, edges. If you observe the edges, I think first one 3, second one 4. 4 plus 6. 4 plus 6, 10. 10 edges. Next one, if you observe clearly how many components, I think 3 connected subgraphs, right? 3 connected, so 3. So 10 plus 3, 4, 13 plus 1, 14. From right side, 14 is coming. Let's go to left side. V is already 9. Regions, how many? Check. Properly check. Regions, how many? Properly verify. I am verifying now. Properly verify. Go there. This is R1. Be careful. This is R2. This is R3. This is R4. Remember, outside is 1. R5. Outside is 1. Total outside is 1. Total outside is 1. You can walk. All outside people, you can walk. I think 5 region. R1, R2, R3, R4, R5. It is 5. 9 plus 5 is 14. This is also 14. Right? Right. Let G be a simple planar graph with V vertices, E edges, R region, and K connected component. Then V plus R is equal to E plus K plus 2. Remember, suppose some people are saying, sir, because of you didn't return connected here, will it work for connected also? Of course. At that time, K connected component, K value becomes 1. Let's see this. Is it planar graph? Is it planar graph? Yes, it's a planar graph. How many vertices? 4. How many edges? I think 6. How many regions? R1, R2, R3, I think R4, 4. Next one, how many components are there? 1. Right now, this side is 8. This side also 8. It will work for both. So if planar graph connected one, this is may be connected, may not be connected. This formula, 2 formulas, please remember properly. What is planar? Can you draw the given crossing? Can you draw the given graph without edge crossing? If you can draw without edge crossing, it's a planar graph. Let G be a simple planar graph with V vertices, E edges, R region, and K connected components. Then this is fine. I hope you got it. Please be careful. I hope you got it. Fine. Yes. Yeah, it's a planar graph story. Many questions are based on three formulas. Either in the planar graph, either this formula they will use, or this formula they will use, or this formula they will use. In the planar graph, three formulas. Any one of the thing will work out. Any one of the thing. Any one of the thing. Right? Fine. I hope everyone is comfortable. And I want to say one important thing. I want to say one important thing to all of you. I want to say one important thing to all of you. Right? Don't miss RIC course. Don't miss RIC course. It is a very valuable course. In the RIC course, you will get 3,500 expected questions with video solutions. Plus, right? Short notes you will get. Plus, formula series you will get. For each subject, it will be very best course to you in the last 6 months. Most of the questions will come from this RIC course and test series. 3,500 questions with video solution in the RIC and test series. Both combinedly, I'm really saying both combinedly, 3,500 best questions and 100 tests will be there. 100 tests will be there, and one more thing is short notes there. Short notes also, and one more thing is formula series also there. Combinedly, I'm giving surety, right? I can say, right? 50 questions approximately. 50 questions approximately, indirectly, directly from this will come. Last year itself is proof. Last year itself is proof. Last year itself came. This year pakka will come. We are trying our level best. Indirectly, directly. I cannot say numbers also matching. Mostly, right? Same model. Everything will come almost same model. Right? Don't miss it if you want to be a topper. Yeah. I think tomorrow's class we'll see the remaining part. I am stopping here. Tomorrow's class we'll see the remaining part. Right? Fine. Thanks. Thanks everyone. Thank you. In tomorrow's class we'll see the remaining part. I'm stopping here. Planar graph started. Tomorrow we'll finish the most of the graph theory part. Most of the graph theory part tomorrow we'll complete. Thanks. Thanks everyone. Thank you so much. Fine. Good night.